Hey guys, how's it going? Welcome to another episode of Ferris Makes Demos. Let's try this again. So if you caught my emulator stream on Thursday, I mentioned that my microphone wasn't plugged in because of my audio setup, because I was playing Switch, and I totally did the same thing again just now, so sorry about that. This is episode 4, where we're going to be continuing to look at some tools that I and some friends of mine have made to basically do demos. And so we've been looking at the 64K specific tooling that we've been working on more recently. This actually goes back a few years. I think last time I even touched this particular piece of code was in early 2015. This is the SNES tracker, or the Super Nintendo tracker. This is the tool that we use to make music in... I think we've only used it in 2 demos now. But Citrix, who I've been working on this with, has made a lot of songs. I think he's made like 10 or 15 different tracks with this thing, which is pretty cool. Only going to be looking at a couple today, one that I've made and then one that he's made. But I think this will be pretty cool just to at least look at this. First of all, hey guys in the chat. Sorry if I missed someone, but John Hunter, Soding, Glenn, how's it going? Dana Collin, Soda Design, New School, Sergey Larionov. Sorry if I didn't pronounce that right. By the way, Glenn, am I going to be in the office around April 7th? Off the top of my head, I'm not sure. Friday, April 7th? Yeah, I think so. I think that'll be last day before I take some time off before revision. So by the way, this tool it's a few years old and it's not open source. It's very much work in progress. So we're going to be seeing a lot of quirks and dumb things just going over this. But I think it'll still be pretty fun. So a little bit of history about this. I started this, around 2013, maybe 2012. 2013, I think, though, is when I started a Super Nintendo Audio Unit emulator. And it was I think the first emulator that I ever started working on, and I mean it went pretty well. It's a pretty straightforward emulator for the most part. Got a cool little CPU. It's basically a CPU, some memory, and a DSP, and that's its own like self-contained hardware unit that the SNES CPU communicates with over a few I/O ports. And yeah, the thing is, I just made that because I wanted to make an emulator, and I thought that sounded pretty fun. But once I had that, I started thinking about, like, okay, if I wanted to do SNES demos, which is something that I had in my head for a long time, could I actually leverage this, and could we, like, make a tool around this? Because, like, I wanted to build everything from the ground up. I wanted to build the sound replayer. I wanted to build all the demo visuals, all that kind of stuff. And there's a lot of work that I put into the visuals themselves, but we're going to save that for another couple streams. This in particular started from the emulator and then just kind of grew out to be what you see right here, which is a tracker. So there's a few different components. There's the tracker itself, which is what we actually use to compose music, and it uses the emulator internally to play music as we're composing, which is pretty cool. And then there's a replayer, which is like this can export to some code that ends up being compiled with the replayer. There's actually a custom assembler in here, which I kind of don't want to talk about because I want to get rid of it. Which, just from a lot of the other old school stuff I did, like it was just another project that I wanted to do. And then I ended up adding some nice features like namespaces and some fun stuff that you wouldn't normally see in an assembler, but were pretty nice. And I actually did that sort of as an extension for some Game Boy stuff I did around 2012. Anyway, a lot of things kind of going into this, but this particular version of this tracker, I was working on a lot in late 2013 and into 2014. And it's mostly, like, I've basically written all the code, but then Citrix, who is a well-known chip musician, has been kind of working close with me to sort of figure out what we actually need to make this thing work. Basic features and stuff. Yeah. We were planning on open sourcing this a while ago, but it just never got finished. I kind of coded myself into a corner with a few of the things and wanted to kind of code my way out before I released it. I'm actually I actually started re-implementing some data model stuff for this in Rust. But it's been a couple years since I touched this. But anyway, I just thought it would be cool that if we start going over some of the Super Nintendo tooling and the Super Nintendo demos that I've done, that this would be kind of a good place to start, because like with 64K stuff, we started with the music tool there, and I thought this would be pretty cool. John Hunter, do you mean SPC player? So SPC in particular is the Super Nintendo audio music format, but what it actually is a save state from the audio unit, right? And so when you want to play an SPC, you actually emulate the audio unit and then load in the save state from the SPC file. So I do not mean an SPC player. This is it's an emulator similarly, but this will, yeah. There's a replayer component that could be played in an SPC player. But yeah, it's a little bit different. So just to kind of give you guys an overview. Actually, by the way, before we dive into that, I wanted to mention, so a user on GitHub by the name of Air the Daybreak has been doing some really, really cool stuff with these streams that I've been doing. He's been making some notes for these last couple ones, in particular the 64K stuff, the 64K tooling, for the tooling, and then the Elysian stream that we did last week. He's been making these really, really phenomenal detailed notes with timestamps, a couple different sort of cleaner ways of representing the information that we went over. And that's been really cool. He did this on GitHub, and then we recently transferred the ownership to my account just to see if we could get more, or so like it could sort of get more visibility and that I would be able to contribute easily. Anyway, I wanted to share that because it's really great. Thank you so much, man, for doing this. I think this is super helpful because I'm kind of too lazy to do this kind of stuff in addition to the stream. So I think it works out really well. So yeah, thank you so much for that. Had to share this. This is really cool. Yeah. So talking a little bit about Super Nintendo music in particular. So like I said, the audio unit is like a CPU and a DSP and some memory. In particular, it's 64K of memory. And that's going to store both your program code and all the sample data that the DSP will use to actually make sound. So I have this little picture here. Now this is actually a debugging tool that I made that doesn't actually run on Windows currently. So I'm not going to show this running, but this was a debugging tool I made to debug the emulator once I ported it to Rust, which is part of, sort of some of the stuff I'm doing there. Basically what you see here is this is the 64 kilobytes of RAM. The blue channel is used for basically what the byte value is. I believe this is 00, but I might have flipped it. So I think this is the first byte and this is the last one, but yeah, I may have flipped that. I can't remember. And then the red channel is how recently that byte was accessed, either by a read or a write. So over time, you can see this change. It's pretty cool. Unfortunately, like I said, I don't actually have this running on Windows right now, so I can't really show it. But anyway, it's pretty cool. And what I want to talk about too is that the DSP in particular, the SNES has 8 different sound channels. And that means it can play like 8 different sounds at once. And the way that it actually plays sounds is that you basically point all the different voices to different positions in this memory. And what it will do then is basically read sample data from there and then play it at different pitches for each voice, along with some envelope stuff so that they fade in and out, and some panning. And it will mix all this together. Now, for a gaming system in 91, this is actually really, really good. So what this is showing here is the voice output for each voice, and then this is the voice output for the whole thing, where I have like the red channel is the left and the teal, like green and blue channels, are the right speaker. And then in this, I also added mute and solos, which haven't made it into the tracker yet. So unfortunately, I won't be able to like solo single tracks, but it should be cool enough to look at anyway. But that's the sort of the main idea about the DSP, is it's basically just pitching a bunch of samples that are already in memory. It also has an echo unit, and this is one of the reasons why I wanted to do my own tool for it rather than just using some off-the-shelf stuff. So like at the time I started this, there's a tool called XM SNES, which can take XM files, which is like a common tracker format, and then convert them to Super Nintendo files, or to basically a data blob that then you mix with a replayer. And one of the things that skips is that the Super Nintendo audio unit also has an echo unit with an 8-tap FIR filter, which is actually pretty cool. In fact, the stuff you see here typically is the echo unit actually accessing the memory here. And I wanted to have a tool that could actually support that as well, and also be a little more like what you hear is what you get. So with one of those conversion tools, because the Super Nintendo doesn't just store the samples in memory uncompressed, it actually has a specific kind of compression called BRR, which is bitrate reduction. And I believe the PlayStation also used a version of this. But basically it adds a certain kind of like sound color to all the samples. And so I wanted a tool that could give me sort of a more accurate representation of what it was actually going to sound like on the system, in addition to giving me a lot of those like echo features. So that's why I wanted to build sort of an emulation-based tracker. Now, since starting this, there's actually been another tool that was released called, I think it's GSS Tracker or something, SNES GSS, I can't remember. But it was made by, I can't remember that either, to be honest. Anyway, it's basically the same thing. Yeah, it's basically someone else also did this. However, they took a bunch more off-the-shelf components and put them together, which arguably is a much better strategy for doing this. And yeah, that's actually publicly available. I think it's called SNES-GSS. Dana Colin, good example of that is in Super Mario World and the castles they use it for echo effects. Yeah, absolutely. Also, if you listen to like any Chrono Trigger song, you'll hear a lot of it. Usually used for echoes and kind of a cheap reverb. It's a really cool piece of hardware. Yeah. So the current implementation of this actually doesn't support the echo unit yet, which is kind of funny. It also, like the echo unit and the filter are not in here. So it basically just is sort of your standard tracker for the SNES. So on this first tab here, now remember, again, this is still work in progress, so there's going to be a lot of things that are kind of obviously wrong or a bit silly or just broken, so bear with me. But in the tool here, we have like these two tabs. There's a tracker tab and an instruments tab. And the instruments tab, we basically have a bunch of instruments. Now, an instrument is both a sample, which is this audio data here. Now, this is the sample data that's been round-tripped through the BRR encoding, right? So we take in a sample and then we can do BRR encoding, and you can see, I don't have zoom implemented on here or anything, but you can see some of the peaks of this are kind of weird. And that's actually because of the BRR compression and the fact that my sample converter that does the BRR encoding is actually not as good as I think it could be. So you get a lot of these sort of discontinuities, but that's the kind of stuff that colors the sound. Like to some degree, you can't really do anything about that, but I think my converter could be a little bit better. Anyway, an instrument is both the sample data itself and then also some metadata about like what is the envelope look like, is the loop enabled. Maybe you can't see that, but as I'm toggling the loop here, we get these like pink lines, which will show where the loop start and end is. I can do like that, for example. And if I hit like buttons here on my keyboard, you can see that it actually starts playing. Now, I don't have anything implemented to show the playback position, but you can kind of hear that, and it's looping if I hold the key. Just pushing different keys. Yeah. So just a bunch of instruments here. Pretty simple. You can export these as waves. You can also import waves. Of course, this will overwrite the current instrument. So you'd want to, for example, take one of these empty slots and then import either an instrument. So this can actually import and export instrument files, which is BSIN encoded, basically the sample data and then all this metadata. So there is like an instrument interchange format, but then you can also just import a wave, which will create a default instrument out of some sample. Cool. Anyway, so you can kind of see how this stuff starts to fit together, but this is basically just the samples themselves. And again, like it doesn't show us what I want to show eventually is like how much memory is filled up and where the samples are in memory. But I don't have that view here currently. Anyway, once we have a bunch of these samples loaded with all this extra instrument data, then we need a way to actually like sequence those and play those. So this is the tracker itself. And each one of these 8 columns here represents one of the 8 different voices. And then I can sit here and like move this cursor around, and just like you'd expect from a regular tracker, sit here and add different notes. So like I'll select instrument. I think this drop down actually doesn't work, so I think you have to select them over here, and then you get those. That's kind of funny. Delete that, for example. And then so what you have in the different columns here is you have a note column, which will, if combined with an instrument column, which is what this is, it will actually start a new, like replay that sample. It'll start playing this instrument with this note. If you just do the note, it will change whatever the note is while still playing the current sound for that track. And then we have over here a couple different kinds of effect columns. So this one we'll do, I think, volume and panning, I think. Let me go somewhere else in the song and see this. Yeah, so this one can do encode volume and panning depending on the value. And then this column over here will select a different kind of effect. For example, we can do like pitch slides. And then the one over here is a parameter to whatever this effect is. So I know this is a bit small, and I apologize for that. But it's basically what I'm trying to show is that this is a pretty sort of bog standard tracker, which is exactly kind of what we need. And then eventually I want to also extend it with some of those other values. But what I wanted to show here is this is the song for a demo that we made called New. Basically the first Super Nintendo demo that I've ever worked on, and definitely the first one that this tool was ever used for. So I'm just going to play this song because I think it's kind of cool. Turn that up a bit. Yes, that's about it for this particular song. There's not that much that's really that technical with it, I think. I think it's actually pretty straightforward. But it was one of those songs that was really fun to make, first of all, because it was made in this custom tool. But second, because it was just supposed to be a really sort of fun and very different track to basically anything that I had ever heard on the Super Nintendo before. If you guys haven't seen this demo, it actually uses video compression for the visuals, which is very liked by some and really not liked by most. But it ends up being kind of cool because you can't really tell because there aren't any visual artifacts. The video compressor is something that I actually think is pretty cool, and I kind of want to talk about that in a different episode. But anyway, the demo is basically a bunch of these sort of free-form flowing shapes. I can post a link to that on Poet. And again, just generally something that was meant to be like pretty fresh on the Super Nintendo. Yeah, and I think the soundtrack fits it really well. Let me find that link really quick here. There you go. But generally, I mean, it's basically exactly like what you would expect. Like there's 8 different sounds playing at once, maybe. We have sort of kick here. I actually have 2 layers of the kick. So the kick itself was one of the things that I worked really hard on trying to get to like sound good. So I basically made what I thought was going to be this song and tried to come up, tried to think about musically what I could do that would work on the Super Nintendo and that would work with a really dry sound. And that's why I use kind of a lot of weird sounds and rely on like pitching and just sort of like a minimal kind of style, is because I knew that the sound picture itself on the SNES would actually also end up being pretty minimal. So I ended up building like a test track in Ableton Live, and unfortunately I don't know where that project went. I can't seem to find it, so I won't be able to show that. But one of the things I did, for example, is like I built the kick in different layers, because if I play this, you'll notice there's a lot of ringing. And most of that's from the compression. It just introduces these kind of artifacts. But that's sort of the bottom, but then there's also the top of it, which is used both in places where like a filtered kick is what I wanted, so I just wanted to play the top, but I think it's also layered in the actual song. Although I could be wrong about that. Like here we just have the top of the kick top there. But I'm pretty sure. Okay, I actually might be full of crap here. And maybe these are just 2 different versions of that same instrument. One of them filtered and the other one not. That's actually probably what this is. There's also a second kick. Not sure what that's for. It's been a few years. I think I wrote this track like exactly 3 years ago. So this is that ARP sound that you hear in the beginning. John Hunter, so none of that is real time. Yeah, it's all sample playback, because that's what the Super Nintendo audio hardware actually does. You're not gonna have like a real time synth on the Super Nintendo. You may have like a decompressor though, but it's gonna decompress to this kind of thing. Here's some hi-hat effects, where you get this kind of tiny click and then this delayed sound here. I like that. Some more of those as well. This is just meant to like create some off time stuff, which I thought made the track a lot more interesting. Like if the sound picture is going to be really sort of minimalistic, then a lot of these sort of rhythmic weird things end up kind of making the style work. If you listen to a lot of IDM like from the 90s, especially in like old 64Ks, you'll hear a lot of the same tricks. Some more click stuff. So I actually have polyphony if I'm holding multiple keys. You can hear that envelope. Drew 2, I think he's asked about visuals. He talked about video compression. Yeah. So the visuals in there are also not real time. I mean, they're real time decompressed. But yeah. The one we did after that is a little bit different, but I'll talk about that in those streams. So this is also just some pad sound, and I believe I made this originally in Live, and then like sampled one note of it, and then that's what this is. And of course added the loop points and adjusted these until they didn't suck. Like if you have this off a little bit, you get this like clicky sound, and we don't want that. Drew 2, yeah, the one after that's the F sharp one. It's impossible for me not to just sit here and play with this stuff. That's the funny thing about these tools. Anyway, there's that sort of that pad sound, and this is used for actually making chords. That's why it's only one note. But I couldn't do that for every pad sound. There's another pad in here, which I call Dolby because it sounds like the Dolby intro, like the kind of thing in the movies. Of course, it's a lot shorter, and it also has this like built-in sidechain sound because I wanted to do this with the kick. And there I just have a minor chord and a major chord, and those are the only two chords that are actually used here. And this sound in particular just didn't sound very good with the individual notes that were distorted and that added together. This sound basically only sounded good if I just took like one chord and then distorted the whole thing and then made that a sample. When you play it like that, you get just like the total 90s really sampled breakbeat kind of stuff, which is funny. I wonder why. Really wimpy snare that I like. And some other sounds here. I think this sound was originally made in, just judging by how it sounds, I think it was made in, what's it called? Razor, Native Instruments additive synth. So a lot of these, like I said, were made in Ableton and then just sampled out. Like that one as well. But it's just meant to be kind of weird sounds.
Jump, 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 jump.
And a lot of these I had to actually clip down, like on the length, to save a bunch of, basically save space. Oh, Duru 2, I didn't know that. That's awesome. Happy to hear it. F sharp is a really cool language. Little hi-hat here. I mean, and that's about it for the different sounds that are in here. And I can't remember what I was even gonna say. Like it's just that straightforward, and then there's just a lot of they're just played together. I really wish I had much more to say here, but I kind of don't. I mean, one of the interesting things about this in particular as well is like we had to, in order to make everything fit, we have to do a bunch of like compression on the different audio data once it's actually in the replayer. So like the audio samples are already going to be compressed because they have to be in that specific compression format for the DSP to actually play them. So those we already get compression there, which is generally okay compression, but not great. It's very predictable though in terms of file size. So those are already compressed, but then the for the audio data, we end up storing them basically like we store them column by column. So I actually take all the patterns in all the songs. So these are all the different patterns which represent stuff happening on each channel. And basically split it up into all the different channels for all the different patterns. And so you can basically say like each pattern here actually becomes 8 different patterns in like column specific patterns. Then I take all those and I deduplicate all of them. So like if 2 of these channels had the same thing on this channel, like you can see basically these left 3 channels are all the same in this case, even the left 4 and the last one. So those would have been interpreted as this is the same pattern as this, right? So we just kind of dedupe all that information. When that is done, then we have the pattern format there being basically like 8 indexes into the column patterns, if that makes sense. So each column is going to be playing those. And then after that, the column data that's left, so for all these different patterns, ends up being basically run length encoded. And that actually works fairly well. I don't remember if I got any actual numbers on that, but basically it was absolutely necessary to do that to even fit this simple song in memory. And that was later improved a bit for the next song, which I basically should just pull up now. So let me pull that up. So this next song, I really don't know my way around, to be honest. But I think it'll be really cool to show. So this song is the song that was used in the Elix demo called Smash It. So this was made by Citrix, also in later 2014, this would have been. And like I said, I don't really know my way around this track, but it's basically the same stuff. We have a bunch of instruments over here. a lot more instruments. And I'll just go ahead and play this as well. Yeah, so that track is nuts. For a Super Nintendo track, this thing is just insane. Citrix is an extremely experienced chip musician generally, and he just went to town on this thing. I really don't have any enough good things. Not any good things. I don't have enough good things to say about just how impressed I was when he came to us with this. And this is actually our backup track. Like originally, we were gonna have a more sort of 80s synth poppy kind of track. But we had some issues with the replayer not actually being able to play it fast enough, which to this day, I still don't actually know what the deal is there. But I think it had to do with the decompression actually being a little bit too slow. Anyway, this track is really, really cool. So I can kind of go through some of the instruments here, although granted, I don't really know my way around here. So just gonna play around here. I love these little breakbeat samples. I know you did a lot of playing around with different kinds of waveforms where the period of the waveform would actually be synced to the whole length of the sample. And I can't remember what he called that. But I think another thing that happens in the export is that we take all the samples, all the instruments that were not actually used and strip them. So I think there's actually a bunch of instruments in here that were not actually used in the real song that he was just playing around with at some point. Also, I don't have a way to cut off notes in the tracker still, I think. So there's a silence sample. Elix sample, which is really cool. There used to be one that said smash it, but this one, it just ended up sounding better. And I think he had a bunch of samples in here that were supposed to say Tursak. Oh, that's super funny. Dora2's YouTube channel is fun to check out. He does these concerts where he plays funky chiptune instruments he builds. Yeah, it's really cool stuff. I'm actually gonna link that really quick. He's called Debug Live on YouTube. He has a couple where he plays other songs from this tracker as well, which is funny. So this is Citrix YouTube. Whoop, and there it is, playing through the speakers. He actually hosts the recordings of our demos, by the way. I should link those, because he had all the video capture recording or all the video recording stuff to actually capture these long before I had that equipment, because he works in AV generally. Excuse me. But yeah, it's really cool. I think he also did a tracker update about this in like November 2014, which is that as well. It's just kind of spamming links. But generally it's pretty cool. Now, I suspected this would be kind of a shorter stream, and it really looks like it is going to be, because we're half an hour in, and I don't really have that much more to add, other than I guess I could go over some of these different commands that are here. Like, for example, C will change the volume of the sample. There's a bunch of pitches that he does here, like 2 is pitch down, 1 is pitch up. What are some other ones he uses? O is arpeggio, so you give it 2 values here, which end up being semitone offsets. So for example, 0C0 is going to, on a cycle, sit there and go from the root note here, plus the root note plus 12, which is an octave higher, and then the root note again, plus 0. 3 is slide to a note, so given whatever note it currently is on, it will slide there. Yeah, that kind of stuff. I can show some of the code, although I don't have all of it building currently. So a lot of it is the custom assembler, and get out of there. And we have, so the code itself is mostly, so it's written in C++ with Qt, and that's a lot of why I'm not that thrilled about it. I use basically a pattern called the observer pattern, which works fairly well if you're doing like WPF in C#. Works really bad if you're doing C++ and not being a little more clever than I was. But I guess the more interesting parts, honestly, are not the actual application code, because it's pretty straightforward, cute stuff. But the actual audio replayer and stuff is kind of cool. So I have this APU driver here. Now, all my assembler files are actually in C# files. So what I do is C# has these verbatim strings. There we go. And what it'll basically do is just emit a bunch of assembler with some extra stuff cooked in there. Like basically just dump these into like virtual files, and then all of those are assembled together. John Hunter 9 points out that this is called SNESticle. Yes, that is the work in progress title for the project. There's my childish sense of humor in my naming scheme. But for example, this is just like the entry point for the audio unit. So like what will basically happen is the audio unit, when it's loaded, it has a little ROM in there called the IPL ROM that's normally banked in, and it will start execution out of that ROM. And all that ROM actually does is basically listen on the input ports that are going to come from the Super Nintendo CPU. And all it does is just listen for like the specific protocol where the CPU will go and load a bunch of data into it, and then it will jump into that data. That's basically all it is. Drew2, homage to Nesticle. I don't think it was intentionally, but I probably heard Nesticle at some point before naming this. Genesis R. Hi, how's it going? So yes, this sets up the global state. This is actually kind of an interesting comment, where the startup state in my emulator wasn't actually matching what happened on the hardware. And actually the one in SNES doesn't seem to match it as well. And I'm wondering if it's between different hardware revisions. But basically the echo volume registers are basically set to different versions, and apparently either different versions of SNESs or different emulators, especially. But like on my hardware, this was definitely one way, but then in different versions of BSNES and different versions of SNES 9X, they were a different way. And it was just the startup state of these echo registers. But it basically meant that the echo unit was always enabled and writing to regions of memory where, of course, I wouldn't have expected it to be enabled on startup. And so the issue then, of course, is that when like starting to play the song, which I discovered at the demo party at this point, it would just play static. And what was happening was that the echo unit was actually overriding the sample and the pattern data, which just made the replayer go insane. Drew 2, Nesticle was the first NES EMU that could run well in like 46. Oh, that's cool. I didn't know that. Anyway, I added this comment to make sure that I could actually make a proper like bug report if the EMUs still haven't fixed that, but I didn't get around to it. I'll set up all that stuff, and I mean this is pretty basic SPC 700 assembler, which is the CPU that's actually in the audio unit. There's also, of course, the CPU driver here, and this is what's basically just going to load all of that into the audio unit and then start playing. Basically, because this is for demos so far, we don't handle anything like restarting the song or playing back samples in addition to playing the songs. It's just load the song, which is basically baked into, like, I basically assemble the song with the replayer data all into one binary, and that goes in the demo. And this code will just load all of that into the audio unit and just let it do its thing, and that's it. Genesis, or if you want to make your inline assembly a bit more dynamic, you can also take a look at ASM JIT library. I'm not really sure if that's, I mean, that sounds cool, but I'm not really sure if that's relevant here because this is not really inline assembler. This is basically just using C# as a preprocessor. But so one of the things that I want to do eventually is this uses a custom assembler that I wrote, which has some nice things about how it handles sections and all that stuff. But generally, what I want to do is take all that away because, first of all, it's based on .NET, which is a dependency that I don't think a tool like this should really have. And second of all, it's going to be a lot more compatible for other people to use if I actually have this code being able to build with WLA. So I think that would be a lot nicer. So eventually, I want to do that when we go for actually releasing this again, but it'll be a long time before I work on that probably, as I'm just working on a lot of other things right now. But yeah, so there's like entry, there's things about input, which I think maybe there was a little bit of input we did. I feel like I hacked together some demo thing for Citrix at one point so he could at least play and stop things. And I think it was for live shows that he wanted to do, where he wanted to at least play and stop the song with just a couple buttons. So I think there is actually some stuff here that does that, which is kind of funny. There's the main loop, which is pretty simple. If it's playing, it's going to tick the time. It's going to check the input. Then there's your main loop. And then it just waits for the timer as well. So pretty simple. The music data ends up getting pulled from a file that ends up being generated by the tracker. So for example, if I go to File, Export, I can export SPC. I can export a ROM that will replay the SPC. And I can also export the source. I can also render a wave of the track. But for example, if I want to do export source, let's see if I can just dump this somewhere on my desktop. There we go. So I think that worked. So what that should have given us is this. So what it gives us is the assembler file itself and then a bunch of these BRR files. And these BRR files are literally binary representations of the samples. And these will end up being linked, like referred to by this assembler, which is kind of cool. Let me pull this up here. Oops, I just totally flashed some code. That's kind of funny. Anyway. Hi.asm. Yeah, that's what I just wrote for the file name. So this ends up being the music data that's also linked in there. Here we have this table of samples, which just point to different samples. Here's the actual music data itself, which is the different instruments here. There's different pattern tables, the different patterns for all the different voices. Here's the raw sample data. And then I think this is instrument data here, but I could be wrong. And then here's the different patterns. This is I believe the compressed data for all the patterns. This is the RLE encoded pattern data for all the different columns. And then we have, that goes on for a while. This is a pitch table. So basically given a note value, you can actually figure out what to put in the registers here. And then that's it. So that's the whole song here for this. I believe that was the Smash It track. Yeah. Which is pretty cool. So then, of course, that gets built with this other code. There's also like the reset thing here. If you want to reset that, start, stop. Yeah, most of this must have just been for starting and stopping the song for Citrix to do live shows. Couple struct definitions, the tick routine, which is really big because this runs basically everything, including the patterns and all that stuff, all written in assembler. And then some variable storage as well. So just kind of scrolling through this kind of quick, but just kind of showing you what the different things are for. Oh yeah, Drew, I didn't realize that C++ also got those kind of strings. Rust has them as well. And I don't think it's that bad of a thing to do, like where I have the preprocessing here, like in C#. It's just that the fact that this goes into a custom assembler is kind of dumb. I could just as well write these to disk and run them through WLA or something. So I would much rather do that at this point. But yeah, and then the CPU driver, again, just basically puts that in and then loads that into the audio unit. And that's about it. And I think there must be a little bit of stuff in here then as well for checking... checking the gamepad inputs for like stopping and restarting the song for live shows, but it's super minimal. Like that's something we want to definitely make a little bit better in the future, but this is just exactly like the minimal thing that Citrix needed to actually play shows. So that's kind of the status of the tool generally, as well. It's like, it's still, I would consider it maybe not early stages because most of the technical problems are solved, but there's a lot of things. Like most of the lower level stuff is there, but we need to like swap out the assembler at this point. We need to fix how a lot of the data model works to make that a lot simpler so that we can make a lot of the rest of the tool a lot more comfortable. For example, there's undo redo supported for a couple things, but not most things, and just a bunch of dumb stuff like that. But generally it works pretty well. Is there anything else that was cool? This is the SPC bootstrap. I wonder what that is. Oh yeah, headers for the for SPC and everything. SPC builder, ROM builder. And there is actually a bit of F# code in here, which comes from Mem and Machine, which is the stuff that drives Smash It in our upcoming demos. But mostly this is just for conversions and stuff. Kind of cool. Apart from that, again, there's a custom assembler, and the assembler is built in kind of a neat way because like there's a generic like assembler and a generic linker. And from there, like those will basically implement everything you would need to do to assemble and link stuff, based on some, what am I gonna say? Some like way to make sections and relocations and stuff. And then from there, you would make that like specialize that on different architectures by specifying like a bunch of instructions. For example, like this for the audio unit. If there's any linker specific stuff, which there isn't here, for example, the SNES APU, but then for like the SNES, there's a bit more things. Specify how the operands work. Pretty classic C# stuff, which is what I was basically writing all the time around when I made this. But it ends up working pretty well. And this is sort of the base on which we build all the SNES stuff that we have currently. Which, again, I would like to replace with WLA at some point, but it's nice for me to use. It's just useless for anyone else. John Hunter 9, does Elix still make demos? We plan on making some more. We haven't for a while, of course. But yeah, I mean, there's no reason why we won't in the future. It's just in the immediate future we probably won't, just because we're working on a bunch of other things. Maybe late 2017 or early 2018. We'll see. We'll see what happens. So this tool eventually I want it to be open source like the rest of our stuff. But this I actually want to be like proper open source. Like the rest of the demo tools that I've been showing, I want to have like a public mirror for in case anyone wants to look at the code. But this is a project that where I would want to actually like properly support it and make a website for it and like really, you know, make a thing out of it. But it's a ways off. It's really useful for us, of course, but would love to take advantage of the Echo unit. Would love to make the code a bit better so I can continue working on this comfortably. There's just a lot of work that needs to happen here, but it's pretty cool. Yeah. Let's forget about that about box. Anyway, I think that was basically all I wanted to go over, was just kind of showing this tool and showing what we're working with. It's pretty minimal, but it drives the SNES audio hardware, which is exactly what it needs to do. And we're able to make at least some pretty cool stuff. Arthur Carlson, glad to see you here. Unfortunately, I'm probably just gonna cut off the stream because there wasn't really much I was gonna show. If any of you guys have any questions, though, I can answer those. But if not, I mean, that's basically all I had for today. Oh, glad to hear you like the emulator series. Definitely gonna keep doing those. John Hunter 9, slightly off topic. Have you ever played Undertale? I love Undertale. Undertale is so good. If you guys haven't played Undertale, play Undertale. Also, if you like metal covers, check out Rashad EB's metal covers on YouTube for like the whole soundtrack, because that game has an amazing soundtrack and he does awesome covers. John Hunter, would it be possible to port that to SNES? Probably. Not trivially, but probably. There is actually like a really silly dream of mine that if someone ever wanted to make a game, but they wanted to have really authentic SNES audio, that I would love to be a part of that and basically use tools like this to make audio with the right kind of constraints. Like, you would actually have to have an API where you would load songs and start songs and stop songs and play audio samples and stuff as if you were writing it against the SNES audio unit, and then we would emulate that. So I would actually love to be a part of that kind of project, and I totally have the tech to do that if anyone would ever be interested in something like that. Kind of a little childish dream of mine, but just saying, it's a thought I had at one point. But me personally, I'm not that interested in making Super Nintendo games. Generally, the Super Nintendo is really not a fun machine to code for. It's something that, because I like grew up with that system, that I really like it, and I really like being a person that makes demos on it, but I actually don't like making the demos on it that much. But yeah, definitely got to do some more, because there's a lot of cool effect ideas that I definitely haven't seen anything close to on SNES that I have that I want to turn into something real eventually. But it's backed up a little bit between other projects. That's about it. But yeah, I mean, again, it's just a pretty basic tracker. It'll arrange some notes, and it'll put them on the SNES. Next week, what I want to do is I want to go over some of the tech behind New, which is the demo that this first song I played here was for. And yeah, basically some of the video compression tech. I got to dig some of that up, and hopefully I can build it. And just talk about how that demo is made, because it's basically made in OpenGL. Thanks, Arthur, for the follow. It's basically made an OpenGL and then video compressed, and the replayer is pretty cool. So I want to go over that. I think that'll be fun. And then the week after, I think we'll go over a lot of the F-sharp based tech behind Smash It, and kind of why I went for that approach. Also, even the video compression stuff is kind of funny because both that and Smash It were basically kind of my idea for this tech that would load stuff into video memory how I wanted it, and then I meant to do like the effects on the CPU anyway. But as I was building that, I realized it could also be used for video compression, which 2 weeks before the party actually made a lot of sense. Anyway, that's stuff for next week, but I think that'll be really fun. So anyway, short stream today, guys, and but I think this is pretty cool. Hope you guys enjoyed it, and yeah. Again, emulator stream on Thursday, and another demo scene stream next week. So anyway, thanks again, guys, for watching, and I'll see you next time.